Good morning or good afternoon or good evening. This is Frank Marascio coming from you live from my room. And this is chapter 7. Might you say you have a green up here? This looks like a golf green. Well, if I wanted to measure the area of this golf green, what I can do is I can snap it to a grid and check it out, or I can use some calculus. You might say, how are you going to use some calculus? Well, what I'm going to do is I'm going to try and find the area under these two curves. And if I can do that, and I made an approximate here, I could find the area of that. And if this was on a grid, I'd be good to go. That's what this next section is about. It's called the area between two curves. It's using integration to get the area. You've seen this before, I think, in AB, but here I'm going to remind you. So, let's say that I had a function f, say that's f, and I have a function, I'm going to use some color coordination here, and I have a function g right here. I have two functions, maybe a happy and sad parabola, if you will. Well, the area of f is everything underneath f. Area is always measured to the x-axis. The area of g would be this stuff. So, if I subtract the two, areas, this would go out, all this stuff would go out, and I would be left with the area inside that figure. Now, that didn't work out exactly the way I imagined, but it's close enough for government work, that's for sure. Formula. I know you want some type of formula. Now, it always works kind of like this, is that the integral of f of x, which would be the top function, minus g of x dx, which is the bottom function. So it's going to be the top function minus the bottom function. That's how we get our area. Simple enough. Let's try some examples. Let's try this one. This says g of x. I'll write a little bit bigger because sometimes my eyes don't see it that well either. G of x equals x, and I'll say f of x equals 2 minus x squared. So we got a line and a sad parabola. Well, I want to find out where they meet. So if I want to do that, I could graph them, or I can set them equal to each other. That's the better deal. If you're doing this analytically, we set them equal to each other. So I'll say x is equal to 2 minus x squared. I'll move things over, so I'll get x squared plus x minus 2 equals 0, and I'll factor it to be x plus 2, x minus 1, so the points that they meet must be x equals negative 2 and x equals 1. That's where the two graphs will intersect. Now, the only thing I need, and these become what I like to call the LOI, or the limits of integration, these guys. So you get negative 2 to 1. Now, which one is on top and which one's on the bottom? Well, there's one way to find out. If I take a number in between the limits of integration, not at the endpoints because they're obviously equal at the endpoints, but if I take a number in between and zeros in between, fantastic. If I take 0 and I plug 0 into both equations, I get 0 here, so g of 0 is equal to 0, and I'll take 0 and plug it in here, and that's an arbitrary number, by the way, just in between. F of 0 equals 2. That one's greater. So the f of x is the greater function, or the furthest away from the x-axis, or it's on top. So I'm going to say it's going to be f of x minus g of x dx, and we're going to get negative 2 to 1. I'm going to get 2 minus x squared minus x. You might say, well, Marascio, why'd you put that in parentheses? Duh. Well, you know why? Because sometimes that's a function that has more than one expression with it, or term, so you need to make sure you distribute that negative to all those terms. Well, anyway, when the smoke clears here, we're gonna do something here. Yeah, it's called integrate. We're gonna integrate, and we're gonna get. I don't want to show that. I'm done. You guys are smart enough to know it. So we do our power rule integration, and we get, I don't know. Talk to me. 2x minus x cubed over 3 minus x squared over 2, and we're going to evaluate all that at 1 and negative 2. All right? So I'm going to plug in 1, and I get 2 minus a third minus a half. Just word to the wise. I wouldn't get common denominators yet, and you're going to find out why. Minus, and that minus is from the fundamental theorem of calculus. I usually like to put FTC sometimes. And then I'm going to put negative 2 in. So let's see what happens. I get, that's supposed to be, it drew a nice line for me. Ah, that's big. Okay. I wanted that. Okay. So I get negative 4 when I plug negative 2 in. I get, oh, help me, 8/3. I hope I'm doing this right. I told you this is the hardest part of the whole thing. And negative 2 into this is minus, I don't know, minus 2, I guess, right? Because it would be minus 4 over 2, which is just 2. Now I'm going to distribute that negative nicely, and I'm going to have 2 minus a third minus a half plus 4 minus an 8/3 plus a deuce. So 2, 4, and 2 is 8. Negative 8/3. Look at this one. This is why you don't do it, folks. Negative a third and negative 8/3 is negative 9/3, which is just minus 3 and minus a half. 8 minus 3 is 5. 5 minus a half is 4.5 square units. That's the winner for the area. You guys got any questions? All right. No one ever asked me questions. All right, here we go. This one. Ooh, we got some trig action. G of x is the cosine of x, and f of x is the sine of x. Nice, nice. Yes, I love them. Oh, I got to give you know what? Like Marty or somebody would say, you need some limits here, so I'm going to go 0 to 2 pi, all right? So I have to tell you that because they're cyclic and they go on forever and all that great stuff. Okay, so now we're going to set them equal to each other and find out where they hit. Where do they intersect? Cosine of x equals sine of x. Where do they equal each other? Or, well, I think they equal each other at pi over 4 and 5 pi over 4. Yes, yes. In the first quadrant and the third quadrant. So that's where we're going. That's where they're equal. Is that right? 5 pi over 4? Am I good? 1, 3, 5. Good. All right. So my limits of integration are 5 pi over 4, pi over 4. Nice, nice. Oh, which one's larger? What's in between here? I guess pi over 2 is in between there. So let's check pi over 2. If I look at the cosine of pi over 2 and the sine of pi over 2, the sine is larger. And by the way, it's just coincidence that all my f's are larger. So it is going to be f of x minus g of x. Okay? I always check that larger thing. So it's going to be the sine of x minus the cosine of x dx. And when the smoke clears on that, it's going to be negative cosine of x minus sine of x, all evaluated at 5 pi over 4. There it goes. And pi over 4. So, let's see if I can do this. Cosine at 5 pi over 4 is negative square root of 2 over 2. So it's just going to be square root of 2 over 2. Negative sine of pi over 4 is negative square root of 2 over 2. So this is also square root of 2 over 2, because it's minus that. Minus the fundamental theorem. Pi over 4 is just square root of 2 over 2. And this one, oh, it's got to be negative, because that's square root of 2 over 2, the minus in front. And the minus in front of this one's negative square roots of 2 over 2. And yes, you're going to get all these square roots of 2 over 2. 4 times the 2 over 2, which is just 2 square roots of 2 square units. That's our area. Yes. So, pretty cool. Anybody have any questions? It's good? All right. Next. I have 2 more for you. This one, I'll rewrite it because, like I said, I don't know. I tried to print it out and be all nice, but sometimes it's not good enough. And this one's not that good. So we got that one is f of x. G of x, I'll factor this out right now. Right now. That's how I work. Let's get 3x, and it's going to be 3x times, I don't know how to do this. I wanted to factor out an x. Minus x minus 10. 10's 5 and 2, so this one's going to be x. 5 and 2, something like this. I don't know. 3x and x. I don't know. I'm not very good at this. Okay. Plus 5 minus 2. That's how we're looking. I think. And I guess, okay, and I don't know why I factored it. I'm stupid. Okay, well, as stupid as I am, I know g of x is negative x squared plus 2x. Well, I'm going to set them equal to each other. See, I'm stupid. I like doing extra math work. All right. So set them equal to each other. So you get 3x cubed minus x squared minus 10x equals this bad boy. All right, this guy moves over, this guy moves over, and we got 0 is equal to, help me. Oh God, this is so hard. This is the hardest part of the whole thing, I tell you. All right, I factor out a 3x, and I get x squared minus 4 equals 0. Holy. All right. So now we're done. And when we set them equal to each other, I find that they intersect at 3 points. All the other ones we did intersected at 2 points. This intersects at 3 points. 0, -2, and 2. So I make a little, this is almost going to be like a sign analysis. Okay? At -2, 0, and 2. Let's take some numbers and plug them in and see what happens here. Well, when I plug we got to look here and here actually. So when I plug 1 in, let's see, when I plug 1 into both of these, let's see what I get. 3 minus 1 is 2, 2 minus 10, I get -8. Here I get -1 plus 2 or 1. So g of x is actually greater here. Let's check -1. When I plug in -1, I get -1 plus -2 is -3. I plug in -1, I get -3 minus 1 is -4, but then this becomes positive 10, I get 6. So f of x is actually greater here. So we're going to need to take the two integrals and put them together, because from -2 to 0, f of x is the greater one, and from 0 to 2, g of x is the greater one. So let's see if I can do that. I don't know. I'm not skilled enough. We're going from -2 to 0, and that's the f of x minus the g of x. So that gets 3x cubed minus x squared minus 10x. And then minus the g of x. See, I put those parentheses in before. Now they're coming up big. Huge. All right? dx. Plus, now I've got to do the other one. From 0 to 2. And now it's the g of x guy minus the f of x.